Hey, what I want to do is go over Graham's law. And Graham's law is a very important law in chemistry, and it's used to show the movement of gases when they're diffusing or effusing. So I would imagine all of you guys understand what diffusion is. You probably were introduced to that in biology. But I want to go over the difference between diffusion and what effusion is. So first of all, diffusion is when particles are moving from high to low concentrations. So you guys probably dealt with this with osmosis. Another way to think about this is if you can imagine if somebody's in a room and they spray some perfume, eventually that perfume will diffuse and you'll be able to smell it throughout the room at some point. Now, effusion is what will happen when you have an opening and the gas particles move through that opening. So if you think about a tire, if a tire gets a hole in it, eventually all the gas particles will move through the opening in the tire and the tire will become flat, and that's effusion. So what we see is that all particles will diffuse and effuse, and the larger the particles are, the more slowly they will diffuse and effuse. The smaller the particles are, the more quickly they will diffuse or effuse. So another analogy, you think about sheep. If you have a bunch of sheep in a pen and you open up the door to the pen, the sheep will probably spread out so they all can eat a lot of grass and they'll spread out into that larger space. And that's our diffusion. Effusion, like I said, is when you get a hole in your tire. Eventually, that tire will go flat because the gas will effuse through that hole in the tire. So let's look at an analogy to help you to understand why gas particles, why it will be related to the mass. So we think about two particles. One is very massive and one is not so massive. Now, if you think about runners, when you imagine if you've watched a marathon, you'll notice that a lot of the marathon runners that finish very quickly in the race are ones that are very small. You do not see the bigger fellas finishing first in a race. They're usually very, very tiny people. And you also think about football players or wide receivers are going to be very small people compared to someone like your linebacker who's supposed to be protecting the different players on the field, but the linebackers are not really the ones that are supposed to be running down the field with the ball. It's the wide receiver. So here we have the very massive particle, which we'd expect to finish last. And if we watch the race, we do indeed see that the more massive particle finishes last, the smaller particles finish first. So let's look at Graham's law. One thing Graham's law says is that we know that at the same kinetic energy, the more massive particles will have lower speeds, they'll be moving more slowly. The less massive particles will be moving more quickly. So the more massive particles will have higher velocity, which is v. More massive particles will have a lower velocity, which is v, and a higher mass. Smaller particles will have a higher velocity and smaller mass, but all particles at the same temperature will have the same kinetic energy. Kinetic energy is dependent on the temperature only. So we then look at Graham's law, which says the velocity or speed of particle A over the velocity or speed of particle B is equal to the square root of the mass of B over the mass of A. And we're talking about the molar mass of B versus the molar mass of A. So make sure you write this law down, and we're going to be using this law in some calculations, and I will show you how to do different types of calculations. Okay, so what I would like to do now is to solve a problem using Graham's law. And what I have here is a problem. This is a typical type of problem. We're going to work through three different types of problems so you guys can see the typical types of problems you're going to see in your worksheet. And this is asking us to find the speed of hydrogen. It's giving us the speed of oxygen molecules. And we also know that hydrogen and oxygen are both diatomic. So we're also going to be able to figure out the molar mass of both hydrogen and oxygen. So we only have one variable, which is the speed of hydrogen. To make it easy, what I did was I set up this problem so that the speed of hydrogen will be on the top. It'll be in the numerator. And this will just make it easy when we're solving. So let's start plugging things in. So we know that the speed of hydrogen is unknown. So VA is unknown. The speed of oxygen is 12.3 meters per second. We know that the molar mass of hydrogen is 2.02 grams per mole. And we know that the molar mass of oxygen is 32 grams per mole. So now we can start plugging things into our equations. So we have VA, which we don't know, over VB, which is 12.3 meters per second, is equal to the square root of B, which is 32 grams per mole, over the square root of, over the molar mass of A, which is our hydrogen, which is 2.02 grams per mole. Now, we're going to first divide 32 by 2, which should give us about 16. 32 divided by 2.02, which gives us 15.84, and that's equal to VA over 12.3 meters per second. Now, when we take the square root of that, what on my calculator, I'm going to be using second, and right above my x squared sign is the square root sign. So you're going to have to see how you enter that in your calculator. So if you are having trouble with that and need to Google Meet with me, that just let me know. But for me, I'm going to do 15.84 and then second and then x squared, second x squared and then 15.4. And I'm going to get 3.9799 is VA over 12.3 meters per second. And when I cross multiply, I get 3.9799 times 12.3 gives me 48.95 meters per second. Now I'm going to round this to three significant figures. So that's going to give me 49.0 meters per second is my speed of the hydrogen molecules. Okay, so that's one type of problem. I want to go over another type of problem. Here it tells us we have an unknown, and we know that it's moving 4 times faster than oxygen. So let's look at our equation again. VA over VB is equal to mass of B over mass of A. So we know that the gas is moving 4 times faster than oxygen. So I'm going to assume that oxygen is B. So VB is equal to X. We don't know how fast oxygen moves. We have mass of B is 32 grams per mole, and that VA is equal to 4X. So the A is your unknown. It's moving 4 times faster than oxygen. And mass of A is unknown. So here we're going to plug this into our equation. So we have 4x over x is equal to 32 grams per mole over mass of A. You notice here we have x over x, and we can cancel those out. So now we have 4 is equal to the square root of 32 grams per mole over mass of A. Now to get the mass out of the square root, we're going to have to square each side. So 4 squared, and then this side is squared. So now we get 16 is equal to 32 grams per mole over mass of A. So we're going to cross multiply, and we're going to get mass of A is equal to 32 grams per mole over 16, which gives us 2 grams per mole, which is mass of A. Okay, and we're going to do one more, so you can see one more type of problem. And then, like I said, you guys have a worksheet to work on. So it says, determine the relative rate of diffusion of krypton and bromine. So remember, bromine is diatomic. So we have Va, Vb is equal to the molar mass of B over the molar mass of A. So bromine has a molar mass of 79.9 times 2 grams per mole. And krypton has a molar mass of 83.8 grams per mole. So bromine is going to be a lot heavier, and it's going to be moving much more slowly than krypton. So I'm going to make krypton as A, since it's moving faster. So I'm going to get a number that's greater than 1, tell me the relative rate of diffusion for krypton and bromine. So Va is going to be krypton. And we don't know that. Vb is going to be bromine. This is going to be our mass of B, and this is going to be our mass of A. So we have Va over Vb is equal to the square root of B, 79.9 times 2 grams per mole over 83.8 grams per mole. So let's plug that into your calculator. So underneath our square root, we're going to have the square root of 2. So if I put that into my calculator, I get that this is about 1.4. So this tells me that krypton will move 1.4 times faster than bromine. If I'd done the other way around and made bromine as A and krypton as B, I would have said that that bromine moved 1.4 times more slowly than krypton. So it just depends on how you set it up, and your answer would have been a little bit different. So I want you to try these problems out, see how you're doing with it, and please feel free to Google Meet if you need to with me to ask questions, or you can email me questions. So good luck.